So we all know that corrosion. So corrosion, if you want to say simply in the sense of just spoiling the metals, or like we can say metals are losing its strength, losing its quality, lost its life, like the strength, physical strength. That is that is what we used to call as corrosion. So this corrosion will takes place because of many factors. That is all we already studied, but of course again we'll discuss. Sure. So what do you mean by this corrosion? If somebody will ask you, what do you mean by this corrosion? Means the spoiling of metal due to the atmospheric conditions. So that is what we used to call as corrosion. Simply, if you want to say, what do you mean by corrosion? So that is why already we studied in chapter 1 last type of reduction or last type of reactions. What is that reactions? Everybody? Redox reactions. Is it correct or not? So we can say the metals are oxidized in moist air. Due to the corrosion, the metals lost their shiny appearance, and due to the corrosion, metals lost their physical strength. So because of that, we will say this corrosion reaction is a what reaction? Everybody? Yes, please. Natural redox reaction. So corrosion is a what? Is an example of what? All of you? Natural redox reaction. So in this, metals are oxidized with what, guys? Oxidized in moist air. So that is what we used to call as corrosion. So now, what is the proper definition for corrosion? Let us see. So the eating up of metals by what, guys? Anybody? By the action of what? By the action of air, moisture, what else? Or chemical substances like sulfur and all. Chemical on their surface is called corrosion. So we can say corrosion is an example for redox reaction. Yes, please respond. So what do you mean by redox reaction? Anybody? Both oxidation as well as what? Respond, Ra. Reduction will take place. So that is what we used to call as redox reaction. I think many examples we practiced for this redox reaction. Am I right, guys? Anybody having doubt? Of course, again we'll discuss. So that is the meaning of corrosion. So because of corrosion, what is happening? The physical strength of the metal will be lost. Physical strength is decreases. Shiny appearance gone. Understanding? They lost their shiny appearance. Okay. So that is the only ways to call as corrosion. So the first example for corrosion, so as we are very familiar, first example is rusting of iron. So rusting of iron is the most common example for corrosion, which we used to experience at least once in our everybody's life. So that is what we used to say. Corrosion also we can call it as rusting of iron. So as we all know that iron particles, when they will come in contact with the moist air and they will get converting into, yes please, a brown color substance will form. What is that brown color substance? That is only we used to call it as corrosion. Am I right or wrong? Everybody? Brown color materials which will form. So that is only we used to call it as what? All of you. A rust of iron. Am I right? Please respond. So what is a chemically what is the rust of iron? Can anybody represent chemically? Chapter 1 already we studied. What is the chemical name of iron? Fe2O3 dot XH2O. Am I right, guys? All of you. So that is the chemical formula of corrosion of iron. Please mark it. Okay, X indicating number of water molecules. So X may be like 1 or 2 or 3 and so on. So place to place based upon the atmospheric moisture, the X will varies. So let us write the chemical equation. So we all know that iron is the solid react with the oxygen, so that what will give, guys? We all studied it in last chapter. This chapter also we studied. So iron is reacting with oxygen. What else? What will form? Please respond. It will form Fe2O3. What is the name of this one? Everybody? Fe2O3. What is the name of this? Ferric oxide. Girls, balance this equation fastly. Girls. No, girl. So 4Fe react with the 3O2 gives you 2Fe2O3. Am I right, everybody? Yes. So that is what. Now this Fe2O3 react with the water vapor. That is what moisture or liquid water, whatever it is. So which will form Fe2O3 dot XH2O. So I'm not specifying here what is the number of water molecules because it will place to place, it will varies. Understand? So XH2O. So that is only we used to call as hydrated ferric oxide. Ferric oxide. That is only we used to call as what? Common name. Everyone? We used to call as rust. Okay. So what is the color of this one, everybody? What is the color of this one?
Brown color.
Brown colored substance. So please remember that. Brown color material. Okay. So now remember the rate of this rusting increases or accelerates. The rusting accelerated in the presence of acids and salts. In the presence of acids and salts, more faster it will take place. So that is what corrosion of iron. So corrosion of iron only we can say rusting of iron. Second one, copper articles. So as we are all very familiar with this. So copper articles, what will happen, everybody? So I used to say, if you go to the old tea shops, the copper tins which they are using for boiling water has been converting into grayish green color coating has been came. So copper articles become green on exposed to air. So exposure to air due to the what, guys? Everybody? Due to the formation of something. Anybody can tell me? What is the name is called as? Chapter 1 also you studied. Due to the formation of basic copper carbonate. Am I right or wrong? All of you? Please respond. So basic copper carbonate. See, for iron, only water and oxygen is required. But copper corrosion, carbon dioxide is also a raw material. Am I right, guys? Please respond. O2 gas plus water. So then it will form CuCO3, copper carbonate dot CuOH twice. So this is what we used to call as basic copper carbonate. What is the color of this one, everybody? Basic copper carbonate. Color what?
Green color.
Green coating. See, for corrosion, either it is a chapter 1 or chapter 3. Okay. So you please always remember only these three equations you'll be having. So even the Statue of Liberty has been converting into light greenish color. Am I right? Because of corrosion. Am I right or wrong, guys? All of you? Already I taught you when I'm teaching also. So that is what. Next. Third one. Third one is very familiar. What is that? Black color corrosion. What is that, guys? Everyone?
Silver.
Yes. Silver. So if you have taken silver, so silver ornaments. So silver also one of the expensive metal. So and other articles, silver articles. So they will become what, guys? Everybody, all of you, they will become black when they expose to air. So means they will react with what? Please respond. When they expose it to air, they will become black. Because the silver article react with what? Everybody. Silver react with something in the atmosphere. What is that?
Hydrogen sulfate.
Yes.
Hydrogen sulfide.
The compound of sulfur. You should not say that, Mitakshri. You should say compound of sulfur, and it will form what? To form what color? Everybody. Black silver sulfide. That is very important. So it will form black silver sulfide. What is that? What is the formula of silver sulfide? Anybody?
Ag2S.
Ag2S. Okay. So this is only we used to call this turning into black only. We used to call some word. I used it and you will find it in our book also. Anybody tell me? Corrosion we cannot. We used to call some word. Anybody can tell me? The dull in appearance of this. I used that word and I asked you vocabulary also very important. Anybody? Even physical properties while I'm teaching also I use the word. Am I taught you the word called as? Yes. Tarnishing. Have you remembered? Tarnishing of silver. Yes or no? All of you. Yes. So the tarnishing of, yes, Vijay, very good Vijay. So tarnishing of silver means this is what? Corrosion of silver only. We can say tarnishing of silver. Can you tell me the equation? Silver, yes please. Silver reacting with hydrogen sulfide. What is the smell of hydrogen sulfide? Anybody?
Rotten egg smells.
Rotten egg smell. Understanding? So hydrogen sulfide, H2S. So rotten egg smell will come. Please write it. Hydrogen sulfide. Rotten egg smell, which will give us Ag2S plus H2. So this is what is that? Silver sulfide. What is the color of this one? Everybody? Black coating.
Black.
So this is what the three equations only you have. So please kindly go through that. All the three equations are very important. Many times, many years they will ask in the exams also. Chapter 1 as well as chapter 3. Again, same equations, same line. Nothing is going to change. But you should learn. That is what we used to say. So particularly the corrosion of iron. That is what we used to call as. What is the name of corrosion of iron? Everybody? Rusting. Okay. So this is the problem of the whole world, not in India, not in Tamil Nadu. So per year, tons of iron getting destroyed due to the corrosion. Per year, hundreds of tons, millions of tons. So that is why many researchers, even you can take Karaikudi Sekri, that is also one of the major research is corrosion preventive methods. So many researchers have been done to protect the iron articles from destroying due to the corrosion. So during rusting, the iron becomes actually like a spongy and brittle in nature. That is the reason I said metals lost their physical strength because of corrosion. They lost their shiny appearance and they become into, because of this corrosion, they will turn into brittle in nature. So what do you mean by brittle in nature? They can break easily. So that is why that physical strength only we used to call as mechanical strength. So the mechanical strength decreases because of corrosion. Whatever the metal, the same thing. So that is why we all should need to take proper steps or proper methods, preventive methods of this rusting, particularly iron. So always we'll speak about iron only. Why means iron is the major one where we will use in many articles. So that is why Copper and silver is also, that's fine. But rusting of iron, that is what corrosion of iron is the major problem across the world, because that is the cheapest one. And every construction areas, many articles has been made up of iron. So whole this concept will run behind only iron. So let us see in the textbook also. So what they are saying exactly, how much it is necessary to read the book, you will understand. So totally 3 points are there. The 3 points, 3 equations. First point is silver. We studied or not? Check it, everybody. We studied the silver, all of you? Yes or no? So silver articles becomes black after some time when exposed to air. This is because reacts with the sulfur in the air to form a coating of silver sulfide. That's what we have done it. Copper reacts with the moist carbon dioxide in the air and slowly loses its shiny brown surface and gains a green coat. So this green coat substance is what, everybody? Basic. What is that? All of you. Basic. Yeah, basic copper carbonate. That is what CuCO3, CuOH twice. Next one, iron when exposed to moist air for a long time. See that. Copper, moist carbon dioxide air. But iron, just moist air. What is the difference between copper and this one? Copper also needs what? Anybody? Carbon dioxide for reaction. But iron only moist air, no carbon dioxide. So it acquires a coating of brown flaky substances. That is what we used to call as rust. So let us find out the conditions under which the iron will get rust. What is the necessary conditions? Okay. So here itself we can say moist air. So it needs two necessary conditions for becoming getting corroded. That is what conditions necessary for rusting. So we should find out. So by using this activity. So that is what they are saying. So totally how many test tubes I have taken here, everybody? Yes, please. How many test tubes I have taken? 3 test tubes I have taken. Okay, everybody. So first test tube, you can see it is a normal air and water rusting of iron nails. So I kept just nails. Second test tube, air, and I have filled with oil. So oil, what it will do, guys? Oil prevents the what? Yes, please. Oil prevents the air, understanding, to dissolve. So in the water, oil cannot be dissolved. Sorry, air cannot be dissolved because oil will work like a barricade. Next, in this one, I am using a anhydrous calcium chloride drying agent. Do you remember this? This one we used already in the second chapter. Anybody can tell me where we have used it? There is a tube called as, yes, Mithakshri, we have used a tube called as God tube. Do you all remember that? For the absorption of moisture. Yes, Mr. Harish?
In moist.
Yes. Anhydrous calcium chloride drying agent. We have used it or not, everybody? So what is the advantage of this one? It will absorb the moisture. Am I right or wrong? So that air will become what? Dry air. Do you understand, everybody? Air become dry air. So investigate the conditions under which iron rust. In tube A, both air and water are present. In tube B, there is no air dissolved in the water. Why? Because oil layer will prevent that. Understanding? And tube C, the dry air is dry. No water, no moisture. Understand? No moisture. Because the moisture which is present is absorbed by anhydrous calcium chloride. That is only we used to call as what? Everybody. Please respond. Drying agent. Drying agent. Let us see that is also. So second chapter we studied or not? All of you? Yes? Yes or no? So let us show you that also. Can you tell me the page number? That is the importance, connectivity. See how fast I will say you. When I see that word itself, I found that it is in chapter. It is in the chapter 2. Am I right or wrong, guys? Everybody? Yes. So that is what is the necessity. You all should work. I think chapter 2 only. Am I right, everyone?
Yes.
So chapter 2, you can see when we are studying. Yeah. So this is what it is. All of you observe. God tube. God tube containing calcium chloride. What is the use of calcium chloride? Here we have written. Everybody? What is the use of drying tube? Check it here. Note. If the climate is very humid, you will be have to pass the gas produced through a God tube. God tube or drying tube containing what, guys? Calcium chloride. Understanding? So calcium chloride to dry the gas. So this experiment we have been proved that moisture is necessary for acid reactions. Am I right or wrong? Moisture is necessary for acids. So acids wants to show their property. They need moisture. Presence of moisture is compulsory for the acids. Am I right or wrong, guys? That is the things we have used it here. So if atmosphere is moisture, we have to pass the gas through this God tube first. And then we have to test the litmus paper, litmus test. So that is the God tube importance here. So this God tube containing what? Calcium chloride, Ca. What is the formula? Ca? Yes, please. CaCl2. Understanding, Amma? So what is the use of this? It will absorb anhydrous CaCl2. Hari, that is also very important. Second chapter, they are saying just CaCl, calcium chloride. But here now they are saying is what? Anhydrous CaCl2 means does not contains any moisture. So that is what. Now tell me which test tube we will observe the corrosion. Anybody? A, B, C. Which one will observe the corrosion? Yes,
Test
please.
tube A.
A. Why test tube A? Test tube B, air is present, but oil is a protective layer which does not allow the air to dissolve in the water. Am I right or wrong? Everybody? Yes, please. So that test tube B, no corrosion. Test tube C, whatever the moisture is present, it will absorb by the drying agent. That is what calcium chloride. So only dry air is present, no moisture is present. So only both air and water are present in test tube A. So that is why where the corrosion will take place. Everybody, corrosion will take place only in what test tube? Please respond, guys. Test tube A. Yes. So what is the necessary conditions for rusting of iron? Necessary conditions. All of you write it. What is that? Necessary for rusting. Anybody? First thing, just now we studied. One is what? Presence of air. Air only contains oxygen. Am I right or wrong, guys? Second one is presence of what? Hurry. Presence of moisture. That's all. So these are the necessary conditions. Conditions necessary for rusting. So please note it down. Do you all understand, guys? All of you? Clear? Mr. Arun, late. Today also late. Johan, understand Johan? Harini? Sanjay? This is. So these two conditions can be fulfilled by the moisture. So that is the reason the rate of rusting becomes very fast in which seasons? Anybody can tell? Rainy seasons or summer season? Anyone?
Rainy season.
Rainy season. So rainy season, the rate of corrosion is greater. So why? So sometimes we may get what rains? Anybody? Sometimes we get what rains? Acid rains. Acid rains, they contains acid. Just now I said, acid rains, what they will do? Acceleration. Accelerate the rate of what?
Rate of rusting.
Rate of rusting. Understanding? So that is the reason rusting requires. What is that, guys? Requires air and moisture. Understanding, all of you? So that is why they are called as two necessary conditions. I hope everybody understand. Everybody clear? Please respond, all of you. Yes, please. Understand, Amma? Clear?
Yes, sir.
So this is what? Now, prevention of iron. Sorry, prevention of corrosion. So basically we are using a word called as prevention of corrosion. But basically we are running behind only what? Prevention of particularly all of you. Rusting. Understanding? So rusting is related to whom, guys? Only it is related to what? All of you.
Iron.
Yes. Corrosion of iron. Understanding? So first method, already what we studied in the chapter 1, the same thing. It can be prevented by painting, method number 1. It can be prevented by oiling, method number 2. It can be prevented by greasing, method number 3. Galvanizing. What do you mean by galvanizing? Anybody can tell?
Coating a
Coating
layer
a
of
thin layer of zinc.
Yes. So dipping the iron articles in molten zinc. Am I right or wrong? That is what coating with the molten zinc is the process we used to call as what, guys? Please respond. Galvanization. Understanding, Amma? All of you? So what will happen if I take a, for example, if I take, listen all of you, if this is the iron article, okay, so this is the iron article. So what will happen if I dip this one in the molten zinc? So what will happen? It will form a layer in the top. So we all people knows. Actually, zinc is more reactive than iron. But what is the advantage of zinc? Anybody can tell me? Zinc, once it will react with oxygen, so it will form a compound called as what? Zinc oxide. So zinc oxide is a what oxide? Inert layer. Understanding? So inert layer. So once zinc oxide will form, further no oxygen supply, no O2 and moisture can goes. Am I right or wrong, guys? Please respond. So that is why inside iron will be safe. Only the coating layer will be getting corroded. Do you all understanding, guys? All of you. So the zinc layer, which is protecting layer here, iron, zinc layer, zinc oxide, corrosion layer is protecting. Is it okay, guys? All of you? Please respond. So majority of household items are designed from galvanized iron only. So whatever you are buying the iron items, everything has been under the galvanized. So zinc is actually more reactive than iron, but zinc will form a inert layer. What is that, guys? What is the inert layer of zinc? Unreactive layer. Inert
Zinc
layer
oxide.
called as zinc oxide. So it will prevent further. The zinc is more reactive than iron. So it will react with oxygen to form a inert layer, unreactive layer. So that is the reason iron will be protected by using galvanization. So that is what here they are saying. You can see galvanization is a method of protecting steel and as well as iron from rusting by coating them with a thin layer of zinc. What zinc? Molten zinc. Understanding, all of you? Molten zinc. So molten zinc means what? Melted zinc. Is it okay, everybody? Melting. So we have to melt the zinc and then we have to coat it. Now, of course, here steel is not a metal. Steel is actually an alloy. For alloys also, for steel also, we will undergo the galvanization so that the lifetime of a steel is further increases. That is the advantage. Okay. Now there is an important, extremely important question here. Mark this point, everybody. What is that? Can you read it? All of you? Yes, please. All you should read that. What is what they're saying? Check it, everybody. Read the question, all of you. Please respond and tell me. The galvanized articles is protected against rusting even if the zinc coating is broken. Can you reason this out? That is the question. Anybody? All of you? I want to know what you people can say. Please respond, Ra. The galvanized article, what they're saying, all of you check it. The galvanized article protected, actually, it is protected with the zinc coating, even though the zinc coating is broken, means there is a damage in the zinc coating, still it will be protecting against the rusting. That is what article protected against the rusting, even if the zinc coating is broken. Can you reason out this one? That is what they are asking. So because, write it. Reason. If the zinc coating is broken, the galvanized object remains protected against rusting. The galvanized articles is protected against rusting. Even the zinc coating is broken because who is more reactive? Zinc is more reactive than iron. Zinc is more reactive than iron. Hence, it can be easily oxidized. Hence, it can be easily oxidized. It can be easily oxidized. Thus, when zinc layer breaks down, when the zinc layer breaks down, comma, the zinc continues to react and get oxidized. Continues to react and gets oxidized. Gets oxidized. Thus, when zinc layer breaks down, the zinc continues to react. Thus, the zinc layer breaks down. The zinc continues to react and get oxidized. Hence, iron object is protected. Do you all understand, everybody? Please respond, Amma. All of you clear? Yes, please. That is one of the most important questions. I hope everybody understand. Please respond, Amma. Yes, please. Okay, everybody. So that is what. Even though the zinc layer breaks also, still it will more react to only. So that it won't be stopped because I physically damage so that I won't react means not. Physically damage also still it is more reactive than iron. So that still it will continue. It will be protected. It will be reacted and will form the zinc oxide layer. So that always it will protect the iron. That is the reason. Is it okay, everybody? Clear? Yes, please. All of you? That is what. Next, we can make electroplating with the tin. You can see here galvanizing. That is what we can say chrome plating, anodizing, and making alloys. Making alloys, you forgot it. Let us discuss chrome plating. So that is what we can say electroplating. What is that one, everybody? Plating with tin, chromium, okay, and nickel. So this is only particularly they are saying here chrome plating. So chrome plating is one of the example for electroplating. So here what will happen? These metals are less reactive and resistance to corrosion. Which one, everybody? Tin, chromium, and nickel. They are having resistance to corrosion. So that is why these metals, by coating the iron articles, see, always we're speaking about iron articles, okay? So what will happen? They can protect them from rusting. So the best example, chrome plating. You all can see bicycle handles. How many of you know bicycle handles? Bicycle handles, we all people knows. Am I right or wrong? Our bicycle handles is actually coated with chromium. Coated with the nickel. The handles of the cycles and bikes are coated with the nickel. Understand, Ra? Clear, everybody? All of you? Chromium. So you can take it here. The handles of cycles and bikes, they are coated with the nickel or they are coated with the chromium. And even the good look, they will give you the good look and they will prevent from the rusting also. And how many of you know cold drinks cans? Cold drinks, not cool drinks, cold drinks. Like you can take tins. Tins you will buy Coca-Cola tin, 7-Up tin and all. These tins actually, they are also coated with the tin, as the tin cannot be affected by food items. Very important one. The tin cannot be affected by food items. So that is the reason the inside, the cooled